Okay, welcome back to another section of our calculus tutorials. This is section 1-4, continuing with definite integrals, this time by trapezoids, using numbers from equations and or data. So, the idea of using trapezoids stems from the fact that if we want the integral, the integral, thought I had the wrong word, the area underneath the curve, it would either be estimating the squares, which estimating can have good or bad things about it because it's not exactly accurate. But in this case, we use trapezoids. We can break up this area into trapezoids, and then if you see, we can find the area of this trapezoid, and then this white space is going to be our error from the estimate. Now, our estimate may be more or less accurate than counting the squares, but at least this way gives us an actual equation that we want to go about, where it'll be exactly the same every time as opposed to people guessing incorrect estimations. Now, what we want to do is calculate the area of all three trapezoids and add them up. Now, to do that, we have divided this curve into three trapezoids. And this is actually, if you recognize the curve from section 1-3. So hopefully we get to about the same answer. Now, let's define this as T of 3, which means we have broken our area up into three trapezoids. Now, the area of a trapezoid is the altitude, which is the absolute height of the trapezoid, or in this case the width, and times the average of the two obscure side lengths. So average of that is 1/2 times that plus that times our width. Now if we notice, each of these trapezoids has the same altitude, which makes it easy. So it's going to be 0.3, our altitude, times 1/2 times, let's see, this one goes up to, let's see, we're counting by 2, so 22 to 34. That's our first trapezoid, plus second trapezoid, once again, the 0.3 times 1/2, sorry, that should be a plus, times, let's see, this one is 34 and 28. And then lastly, plus 0.3 times 1/2 times, let's see, we have 28 and 4. Now, you probably want to just go ahead and plug all this into the calculator, plug and chug, get an answer, and that would get you your right answer, or at least our estimated answer. However, let's analyze this a little bit and see if we can come up with a better formula, because right now it's pretty messy. First thing, if you notice, we have a 0.3, a 0.3, and a 0.3. Everything has a 0.3, so I can factor out a 0.3. I can also factor out a 1/2. Everything has a 0.3 and a 1/2. Now, what's left? We have 22, but we have just one of them. We have two 34s. 2 times 34. Plus, let's see, two 28s. 2 times 28. And just one 4. Now, I'm going to factor this half back in there to get rid of these 2's. So we have 0.3. And then in parentheses, we're going to have 1/2 of 22 plus 34 plus 28 plus 1/2 of 4. And this is going to be our integral. Now, I did this because it's going to be very helpful for us in a minute. Now, if I do this math, let's see, I didn't pull up my calculator yet, so I'm just going to do this by hand. We have 0.3. Let's see, 1/2 times 22 is 11. 34 plus 28 is 62. 1/2 times 4 is 2. Let's see, 0.3. We have 11 plus 62 is 73. Plus 2 is 75. 0.3 times 75, I'm going to do the math over here. 15, carry the 1. Let's see, 3 times 7 is 21, plus that is 22. We get our estimate as 22.5. Now, if I remember right, we got something similar with the other one. In this case, it looks like we're even less accurate, but that's because of this white space here and here and here. Now, to get rid of that white space, to make it even more accurate, we want to make our trapezoids try and match the curve better. Now, before we do that, let's talk about this equation we came up with here. Now, if you notice, we can pretty much apply this to any set of trapezoids. We are going to call this the trapezoid rule, which you see on the next page. So if we took that same curve, cut it up into a bunch more trapezoids, notice that the shading comes really close to the curves. Now, let's talk about the trapezoid rule. The trapezoid rule says T to N, so last time we cut it into 3 trapezoids, this would be 3. In this case, we're going to cut it into 1, 2, 3, 4, 5, 6, 7, 8, 9, so it would be T of 9, equals change of X, which means how wide the trapezoids are, times 1/2 f of A, which would mean this height, 1/2 of that, plus f of the next x, f of the next one, and the next one, etc., until we get to x n minus 1, plus half of the last one. And this would get us our integral without having to do every single one individually. Because if we look over here, okay, half of the first height, plus the second height, plus the third height, plus half of the last height, add all up, multiply by the change of x, and that's it. Now, let's come back to this and finish up and see how much more accurate this is here. So, let's see. First of all, I believe I'm going to want my calculator for this. Now, I'm going to show you guys how to pull this up probably in the future, but there is a calculator that we can download that is a graphing calculator you can use on your computer. Looks like this. I'm going to go ahead and start a new one. Start it, and there is the calculator on my computer. Now, if you want to know how to do that, just ask. Now, our function, whoa, my cursor is messing up. Let's see, what was our function for this one? It was, looking in the book, here it is. F of x equals negative 100 x squared plus 90, man, my cursor is really messing up, 90x plus 14. I want that equation because I'm going to go ahead and plug it in my calculator so I don't have to keep on retyping it in. Alright, so we have negative 100 x squared plus 90 x plus 14. And now I'm going to go into my table, but those aren't the values I want. I want from 0 to 1 counting up by 0.1s. So from 0, counting up by 0.1s. Now, here's my heights. Starts at 14, which we see. Looks like it messes up every time I switch between. Next we have 22, 28, 32. So 22, 28, 32, 34, 34. Let me see my other ones. Looks like it's going to repeat going back down. 32, 28, 22. Yep. (22), 14, and then this last one I believe was 4. Let me just double check that. Yep, 4. Alright, now we have our numbers and we can plug it in to our equation. Now, each of our trapezoids is 0.1 wide. Now we have 1/2 of the first one, which is 22, plus 28, plus 32, plus 34, plus 34, plus 32, plus 28, plus 22, plus 1/4, plus 1/2 of 4. And this will give us the integral using 9 trapezoids. Now this should be a more accurate estimation than what we just had. So I'm going to go through and plug all this into the calculator and see what we get. So everything is times 0.1, and then we have 1/2 times 22 plus 28 plus 32 plus 34 plus a second 34 plus 32 plus 28 plus 22 plus 14, and then plus 1/2 of 4. 23.7. So T of 9 is 23.7. I believe that's what I had. Let me just double check. Yep, 23.7. Now, if we compare that to what we just had, 22.5, it's close, but it's more exact. I believe it's even a lot closer to what we had the last time. So, pretty much all you got to remember is try to use the trapezoid rule if you have to do this. Okay, it's going to be a lot simpler than calculating 9 separate trapezoids and adding them up. Okay, so coming into this formula is going to be helpful. Alright, I'm going to go ahead and end this video and then start one after picking out a problem from this problem set.